Many theories attempt to picture just how and when our planet was formed. But until recently, there's been little hard evidence to go by. Now, however, a new discovery has thrust before the world a revolutionary model of our origins, forcing many scientists to consider the unthinkable.
The startling new evidence is found deep beneath the Earth, below layers of sedimentary rock down in its primordial stones, the granites. There, tiny bits of radioactive matter have formed what scientists call radiohalos. They've left telltale traces, creating a discolored sphere around them. Scientists can identify precisely what kind of material caused these radiohalos by measuring their sizes. One U.S. scientist, Dr. Robert Gentry, has examined more than 100,000 of these phenomena. Dr. Gentry has discovered a type of radiohalo that just shouldn't be there. In fact, according to every basic principle of evolutionary theory, it just can't be there. It's impossible. But after years of vigorous experimenting and testing, there is now no doubt.
I have identified polonium radiohalos in the Earth's basement granites from America, Canada, Scandinavia, Europe, Russia, Japan, and Madagascar. This is extraordinary because these polonium isotopes have a very fleeting existence. One type I've identified, polonium-218, occurs for only a few minutes before decaying into something else. And yet this radioactive element has imprinted its identifying halo in solid granite, in particular in these pieces from the White Mountains in New Hampshire and from Neji in Japan. In granite, halos are found in this dark mineral called mica. The mica must be thinly sliced or peeled with tape and then mounted on a glass slide before halos can be observed. Animation helps us to understand the origin of the three-ring polonium-218 halo now seen under the microscope. The three sunburst patterns shooting out from the tiny center represent three different energy nuclear particles that were successively ejected from three different isotopes of polonium encased within the tiny center. The accumulated effects of millions of such particles discolored the mineral around the center, thus producing three microscopic-sized, concentric colored spheres. In the mineral, the halo is always three-dimensional. Under the microscope, however, it looks flat. By taking a thin slice of the mineral through the center, we have effectively cut off the top and the bottom of the spheres and are thus left to view the halo as a series of three concentric rings under the microscope, as is illustrated in this animation sequence. According to all present scientific theories, granites, such as this specimen from Pikes Peak in Colorado, originated in a molten state, cooled, crystallized, and hardened over millions of years deep in the earth. But if that's the case, the radioactivity produced by polonium would never have been captured. It would have decayed away long before the rock solidified. The grains of polonium that made these radiohalos were embedded deep in the granite. The element was there somehow when the rock was formed, but it could only form its radiohalo after the rock had already hardened. And if polonium exists for only a few seconds or minutes, the implication has stunned all those who are willing to listen. Polonium radiohalos indicate that the Earth's foundation rocks, the granites, were formed almost instantly. In fact, they are evidence that the granites had to be formed instantly. Scientifically, they cannot be accounted for in any other way.
David Gentry, son of Dr. Robert Gentry and associate in his father's work on creation.
We can demonstrate the principle of polonium radiohalos. Imagine this Alka-Seltzer tablet is a bit of polonium, and this glass of water is a piece of molten granite. I drop the tablet in, and it begins to fizz. Think of these bubbles as the radiation emitted by that bit of polonium embedded in the granite. This fizz will go away in about 30 seconds and we'll have nothing left but a slightly tangy glass of water. Now, is there any way we could preserve these bubbles as they are? We could try placing the glass in the freezer. The water, of course, would solidify after a while. That's something similar to what evolutionary theory suggests, that molten rock slowly cools to form granite. But as you've already guessed, freezing this glass of Alka-Seltzer wouldn't do any good. The bubbles will have gone long before the water turns to ice. And that's exactly what would have happened to polonium radiation if the granite had slowly cooled. It would have disappeared long before any radio halos could have been imprinted in the solid rock. If I show you a frozen glass of water with all the fizz of a tablet still intact, like this, you will know that something happened to instantly freeze the water. In this case, we merely froze it instantly in time by a pause of the videotape. Likewise, if we look at a radio halo demonstrated unmistakably to have been produced by a certain kind of polonium, we can know that the granite around it had to be formed instantly.
The implications are incredible. If Dr. Robert Gentry is correct, all the evolutionary assumptions about the Earth forming over millions or billions of years are wrong, and the account in Genesis of the creation of the Earth is substantiated. But is Dr. Gentry right? Is he just some maverick scientist conducting his work in virtual isolation? If his experimental results were brought to the light, would other scientists be able to quickly discredit them? As a matter of fact, Dr. Gentry conducted most of his research on radio halos at the Oak Ridge National Laboratories in Tennessee. His findings have been published in many of the world's leading scientific journals: Science, Nature, Geophysical Research Letters, Earth and Planetary Science Letters, Physical Review Letters, Annual Reviews of Nuclear Science. Papers appearing in these journals are subject to peer review. That is, other scientists in the same field carefully examine the evidence presented and the experimentation used to see if there are any flaws in the data.
So far, it seems no one has been able to contradict Dr. Gentry's findings. No one has been able to find a hole in his case.
In December of 1981, Dr. Robert Gentry was called to testify at an Arkansas trial in which the American Civil Liberties Union attempted to prevent the teaching of creation science in that state's public schools. He presented his findings regarding polonium radio halos as evidence of an instantaneous creation of the granites. The ACLU brought one of the world's foremost geologists, Dr. Brent Dalrymple, to testify for evolution. But on the witness stand, no scientific evidence was offered to challenge this discovery for creation. Instead, it was referred to as, quote, just a tiny mystery that we can't quite explain.
With that background, let's step back and get a bigger picture in order to place this revolutionary discovery in perspective. In particular, how does it impact on the age of the Earth?
All attempts to determine the age of the Earth are based on radioactive decay. Heavy elements like polonium and uranium are unstable. Their atoms tend to break down or decay by ejecting alpha particles. Over a period of time, unstable atoms decay through a chain of steps into an entirely different, stable atom. Unstable uranium, for example, eventually becomes a type of lead. Scientists have observed that radioactive elements decay in the present at incredibly constant rates. They can predict exactly when an element would pass through each of various stages in the decay chain if present rates persist. Geologists have thought that they could use decay rates to tell geologic time, the age of the rocks. They study rocks that contain samples of radioactive elements. By using complex scientific equipment, they examine traces of uranium in granite, for example, and figure out precisely how much of the uranium has decayed into lead in the rock.
Then, based on present rates of decay, they figure back to the time when that uranium first began to decay. That, they reason, should be the rock's starting point.
A piece of granite rock has been loaded into this instrument. It is called an